All right, so we're just going to do one lesson today. We've got quite a bit of vocabulary to talk about when we're talking about circles. Just want to make sure that we're clear on some words because you're going to be hearing them a lot. So most of you know some basic things about circles. Obviously, this point in the middle is called the center. Most of you know that if you take any point that goes from the center to the, I say the edge of the circle, but really it's on the circle itself, that is called a radius. And then if you have a segment that's going to run from one end of the circle through the center of the circle to the other end, that's going to be called a diameter. Wow, I'm not even spelling that right. D-I-A-M-E-T-E-R. All radii in a circle are congruent to one another, and all diameters drawn in a single circle are going to be congruent to one another. Otherwise, it would not make that circular shape that you know and love. So there are a few other segments in a circle that we need to know about, and this is actually not an extensive list. We're going to add a few more things as we go, but these are the ones that we need to know for today. So a chord is a segment whose endpoints lie on a circle. So for example, AB is a chord here. BD is also a chord because I'm going from one end of the circle to the other, not like a diameter which would go specifically through the center. Central angles are angles that are going to have a vertex at the center. So for example, angle ACD here, that's a central angle. The other way, ACD, those are both central angles because their vertex is on the center. An inscribed angle is going to end up having a vertex inscribed, which is going to be on the edge of the circle. Think about the inscribed triangles that we drew yesterday. Those ended up being the vertices on the circle. Same thing with the angles. So inscribed is where the vertex is on the circle. So I would at least have one of these pictures drawn with those things labeled. And in addition to angles relating to circles and segments relating to circles, we also have arcs in circles. So circles really have three parts, even though when you look at them, you would think that they wouldn't be quite that complex. So an arc, you might think arc sounds like the word arch. So arc is just like a portion of the circle. So for example, in this first one, we're talking about a minor arc, which is an arc that is less than 180 degrees. All right, so this right here is going to be a minor arc. Notice how they write arc here. So they're going to write arc with this AB with the little arc symbol over the top of it, so it looks just like an arc, the same way we do for angles. And then they're going to give you this other piece of information, and that's that the measure of the arc is equal to the measure of the central angle. So for example, if this central angle here is 80 degrees, then we would say the measure of that arc is also 80 degrees. That's how you would measure that, what I have drawn in red there. So let's look at a few others. So you've got minor arc, then we have major arcs. Major arcs, you must use three letters to indicate that you're going, which direction you're going around the circle. And major arcs are going to measure greater than 180 degrees. So we're talking about more than half the circle. So here, this says arc ADB. That means I need to go from A to D to B. All right, we can't just say AB, or that doesn't tell me to go that direction. And then a semicircle is an arc. The measure is going to equal 180 degrees. So, and you still need to use three letters so that we talk about which half of the circle we're going to be indicating. But a semicircle is exactly what you think it is. It's half of the circle's arc. And just like with angles and segments, we haven't done this in a while. It's been really since the beginning of the year since we've talked about angle addition and segment addition. But remember, that was taking two smaller angles and making a larger angle, or two smaller segments and making a larger segment. Arc addition works the same way. It works with what they call adjacent arcs, just meaning that the two arcs share the same point. So for instance, in this image at the top, DE and EF are adjacent arcs. They're right next to each other, both sharing the point E. And what arc addition is going to say, and I'll use this top circle as an example, it's going to say that the measure of angle, the arc, the measure of arc DE plus the measure of arc EF. So if I add those two arcs together, I'm going to get the larger arc, which is the measure of arc DF. If you want to pause the video, you can, but what's in the box down here for arc addition literally says the exact same thing. They do use 3 letters to name this arc, though you don't have to do that. You can just simply use the same 2 letters since that's a minor arc. All right, so let's do one example just to talk about what we've learned so far, and then we'll add one more little postulate or theorem. All right, so this question talks about an arc moving, and it says the minute hand starts at 10 after and is going to move to 30 after. And it's asking what is the measure of this arc. And when it says measure, it's asking for a degree measurement. All right, so some things that we need to know to do this problem. First of all, this is a central angle that we have here because the vertex is on the center. And so since the vertex is on the center, that means this arc is going to be equivalent to the central angle. So my job needs to be to figure out what is this central angle. And to do that, there's a handful of different ways you can do that. I'm going to just set up a proportion here. I know that in the entire circle, let's see, there are 12 segments, and I've used 1, 2, 3, 4 of them. So 4 out of 12 segments. And if I'm converting this to degrees, I'm looking for some degree measurement out of 360 because the circle has 360 degrees total. Now, if you work that out, you should get that x, or that central angle measure, is going to be, let's see, 1/3 of that, so 120 degrees. So I know the central angle measure of the hand itself is 120 degrees. And then because central angles and arcs are congruent, I know that means the measure of the arc, wow, spelling is not my thing today. Measure of the arc is going to equal, 120 degrees. All right, so let's add our last little postulate or theorem here. And that is this theorem right here. It talks about inscribed angles. So we've said what inscribed angles are. We know that that means that we've got a vertex here on the circle itself. And I'll zoom in here for us on this theorem. This theorem says that the measure of the inscribed angle is half the measure of the intercepted arc. So that means if this intercepted arc up here is 80 degrees from A to B, then this angle measure is going to be 40 degrees. Now remember, that central angle measure coming from the center is still going to match the arc angle measure. So it's still going to be 80 degrees. All right, so just so you can compare all of those different things. All right, so I'm going to try not to make your brains explode, but we are going to do one more example trying to tie all of these things together. All right, so they want us to find some different arc measures. So the first thing they're asking for is the arc measure of DE. And what I think that seems appropriate is I need to be looking for either an inscribed angle that can intercept that arc or a central angle. Well, in this picture, I don't have any central angles. I have nothing that's coming with a vertex from angle C, but it does appear that I've got this angle EAD right here that is intercepting that arc ED. So that means that this measure angle A is half. Ooh, I did not mean to undo that. This measure of angle A is half of the measure of the arc, which means the arc will be twice as large. So that's going to give me that the measure of, struggling today, arc DE is going to be equal to 108 degrees. Okay, so I'm going to label that. The next thing they're going to ask for is the measure of arc BD. And since they don't say 3 letters, I'm going to assume that that's this minor arc, which is the correct way to interpret that. And to me, that looks like 2 different arcs there. I've got an arc B to E and E to D. So I can add those 2 together, which is going to give me a measure of angle 126 degrees. And our theorem there is going to be arc addition, because I'm adding 2 arcs together to get the smaller one. The next thing they're going to ask is for the measure of angle DAB. So that's going to be this whole angle right here. And it looks like I need to find this other little part so that I can add those together to get the entire angle. Well, I'm going to be using a combination of things, but I know that that this small piece right here gives me a smaller angle, or sorry, an inscribed angle. So if the arc is 18, then that small angle measure is going to be 9 degrees. So my total answer here looks like should be 63. And to do that, I use that inscribed angles are half of their arcs, and I used angle addition because I ended up adding 9 to 54 to get the entire angle there. All right, and this last one is kind of my favorite. They're asking for the angle of measure of ADE. And so this is an inscribed angle, which means I'd probably need to know something about the arc measure. And a lot of times people look at this arc and say, oh, well, I don't know anything about that arc. But you actually do, because this whole arc is a semicircle. All right, notice that A to E, it's kind of hard to see because I've written over it now, but A to E is the diameter, which means this whole side is 180 degrees. And then angle D, because it's inscribed, is going to be half of that. So that means the measure of angle D is going to be 90 degrees. So I've written my reasons out there. Diameters make semicircles, and inscribed angles are half. I hope that that helps you make sense of some of this stuff for circles, but we are going to work on this together tomorrow.